Okay, this is day 7 of my live coding through Advent of Code, and let's see how it goes. So, day 7, problem 7, Recursive Circus. Wandering further through the circuits of the computer, you come across a tower of programs gotten themselves out of hand. A recursive algorithm has gotten out of hand. They're balanced in a large tower. One program at the bottom supports the entire tower. It's holding a large disk, and on the disk are balanced several more subtowers. At the bottom of these subtowers, standing on the bottom disk, are other programs, each holding their own disk, and so on. At the tops of these subtowers, many programs stand simply keeping the disk below them balanced, but with no disk of their own. You offer to help, but first you need to understand the structure of these towers. You ask each program to yell out their name, their weight, and if they're holding a disk, the names of the programs immediately above them balancing on that disk. Write this information down. Unfortunately, in their panic, they don't do this in an orderly fashion. By the time you're done, you're not sure which program gave which information. For example, if your list is the following, PVGA, XH, blah, blah, blah. So this guy's got 3 on top of him, which are him, him, and him. Then you would be able to recreate the structure of the towers that looks like this. Oh, I see. So I've got everyone. I just so if I do FWFT, he's got, oh, so those are his 3 immediate children. And if I do TKNK, those are his 3 immediate children. If I do UGML, those are his 3 immediate children. Okay, so that's relatively easy. And so I would call this the top of the tree. But anyway, calling this the bottom of the tower, and it's holding up those 3. Those programs holding up other programs. In this example, none of those programs are holding up any other programs. And the actual tower balancing in front of you is much larger. Before you're ready to help them, you need to make sure your information is correct. What is the name of the bottom program? So that's TKNK. Okay, so that shouldn't be too bad. The name, let me just see what the puzzle input looks like. That will help us out a bit. Okay, so it looks like that thing. So the bottom program is going to be the one that has children, but is not anybody else's child. Obviously. Maybe not obviously, but that's what it's going to be. Has children, but is not anybody else's child. So, day 07 circus. I don't know what's called circus, but and as always, I'll put this here. Okay, so we want to let me get this test input. So we're going to need to do a little bit of string processing, if you will. So test input equals, and here I'm probably going to lead with def process input, which is a string. I don't know what it's going to return. So, but we want to make a sense of this. And let's just process line first, which is a line, which is a string. And again, I'm not going to put a return type yet because I don't know what it is. So we want to process each of these lines. And so one thing I'll do is I'll say parts equals line.split, and it looks like, you know, if there's children like this. So head equals parts 0. What are we calling these things? We're calling these towers. So let's say tower equals parts 0. And then we call them, do we call them children or what? The names of the programs immediately above them. So what will I call those? Aboves equals, so it could be nothing if there's only one part. And otherwise, it's going to be parts1 dot split, and it looks like they're split on comma space. So that's going to give me the aboves, and then we want to get the weight. So let me use a regex for that, and one should never do regexes in public, but so are the towers all four? No, they're not all 4 letters. So the towers are all, let's say, A to Z plus, it looks like. So I want to capture that. Then I want a parentheses. A parentheses capture something, 0 to 9 plus parentheses, and then a closing parentheses like that. And so let's say regex dot, or no, re dot match regex and this. Let's see if that works. Okay. So, and then I always forget how this works. m.groups KTLJ and 57. Good. So let's try this out. Regex is that, so let's do in import re, and we're just going to assume that this matches equals re dot match regex with tower, and then we want to do it, and this is getting name weight equals match dot groups weight equals int of weight, and so we're going to from typing import named tuple, let's call this tower, and I'll use the new style named tuple because I think I can do it now. Class tower from named tuple. So it's going to have a name, which is a string, and it's going to have a weight, which is an int, and it's going to have some aboves, which is going to be a list of strings, which will just be their names. And so that means I need list as well. And I want to return tower name weight aboves. And so let's write a couple of tests. Process line of, nope, that's not it. Let's write 2 tests. So if that's my line, that should be the tower with name is FWFT. Oh crap, I'm off the screen. Okay, so, sorry, I was off the screen. So that should be, and this is bad form, but I'm doing it anyway because it'll make it more readable. Tower with FWFT 72 and KTLJ, CNTJ, and XHTH. And similarly, I want to assert that process line, let's get this one here, of havoc 76 equals a tower, and of havoc 66 and an empty list. So let me, what doesn't like about this? Doesn't like it because it doesn't like 3.6 syntax. That's fine. Run day 06, that's, whoops, that's yesterday. Run day 07 circus, assert process. What's the invalid syntax? Let me try that, see if that makes a difference. Nope. Assert. Why is that invalid? Because I didn't close something, maybe? Let me put these out and see what happens. Print process line of. So let's see what that does. If I print it, too many values to unpack. Name weight equals match dot. Is it match dot groups? Is that right? Okay. And print process line havoc 66. Attribute error. None type has no match groups. How could that not work? So tower equals havoc 66. Actually, you know what? Let me print tower just to make sure that it's doing the right thing. Havoc 66. So it's not capturing that second. And why is that? Let's add a print parts. Okay, this is going dodgier than I wanted it to. Because I forgot to close it. Okay, that's better. Okay, so that actually seems right. So why did my assert not work? Assert process line of this thing equals, did I not close this properly? I did not close this properly. Okay, so that was my issue all along, and those pass. Okay, good. Let's do part one, and part one wants us to find the bottom. So let's find the bottom. Deft find bottom, and let's say towers is a list of tower, and it's going to return a tower. Okay, and so I have a bunch of towers, and what I said is I want to find all the towers that are children. So our children, let's call them R aboves, is going to be a set of, I'll just make a set of towers. It equals set, and have aboves is also a set of tower, which is going to be a set, and then I'll say for tower in towers, if tower dot aboves, so if it has things that are aboves, have aboves dot add tower, and then for above in tower dot aboves, are aboves dot add tower. And so what do I want? I want the tower that has aboves but is not above. So valid, let's call those good, equals tower for tower in have aboves if tower not in are aboves. Assert that there's exactly one like that, and then return it. So with our tests, test towers equals process line for line and test input dot split on new line. Okay, so let me run this and look at test towers. So that seems reasonable. And then if name equals main, print find crud. Okay. Usually I put a post-it note on my screen to like mark where I'm not supposed to type, but I don't have any post-it notes, so I hope I'm not off the screen too much. I'm trying to be good about it. Print find bottom test towers. And you know what, maybe I'll even move this inside. Actually, no, I won't, because this isn't even what I want to do. I actually wanted to just write a unit test. Assert find bottom test towers dot name equals, and then the test tower at the bottom is tknk. So this isn't actually the solution. That's just the problem. Unhashable type list. I can't add it because, okay, that's fine. I'm just going to make these sets of names. That'll make our lives easier. Because it's not liking that there's a list component that I'm trying to add. I could change that by making it a tuple, but I'm not going to do that. It's easier to just store the names of the towers. Okay, so that didn't work. So I got nothing. So print have aboves and print are aboves. It's possible I got this backwards. Above.name. Maybe that's the problem. And it's not above.name, so I'm just storing strings. And tknk, so that's good. Let's get rid of that print. And I think we're happy with this. So now let's save this input. Save as, call it day 07 input.text. So let's say if name is main with open day 07 input.text. I really need to remember this post-it note as f towers equals process line dot strip for line in f and print towers. Let's just do that and make sure that it works right. Okay, so that's a lot of towers. Print find bottom of towers. So now if I run this, it's saying it's FBGGUV. Okay, well, let's find it. FBGGUV. That actually is a tower and it has children, so that seems reasonable. What is the name of the bottom program? So let's paste that in and say that's the right answer. 1 gold star. Okay, and you might be wondering, I went to all this trouble to pull out the weight in this regex. Why did I do that since that wasn't even part of the problem? Well, it's there, so it's probably going to be part of part 2, was my thinking, and let's see if it actually is part of part 2. Programs face the situation they can't get down, or they could get down if they weren't expending all of their energy trying to keep the tower balanced. Apparently one program has the wrong weight, and until it's fixed, they're stuck there. For any program holding a disk, what does that mean, holding a disk? That means for any program with subtowers. Each program standing on that disk forms a subtower. Each of those subtowers are supposed to be the same weight, or the disk itself isn't balanced. The weight of a tower is the sum of the weights of the programs in that tower. In the example above, this means for UGMIL's disk to be balanced, those three have to have the same weight. However, for TK to be balanced, each of the programs standing on its disk and all programs above it must match. This means everything below it. As you can see, it's unbalanced. Ugmil stack is heavier than the other two, even though the nodes above Ugmil are balanced. Ugmil itself is too heavy. It needs to be 8 units lighter. If this change were made, its weight would be 60. Given that exactly one program is the wrong weight, what would its weight need to be to balance the entire tower? Okay, that's sort of interesting. So, the first thing I want to do is, let's balance tower, balance towers. I'll call it that. Towers is a list of tower. And I won't put a return type because I don't know what it needs to be. And so the first thing I'm going to do is I just want to get lookups equals tower.name tower for tower in towers. So now I can very easily determine a tower by its name. And so what do I want to do? I want to say let's a function and a function is not great, but let's say a function def is balanced some tower, which is a tower bool. And so you know what, let's actually call this subweights tower, and this will be a dict from string to int, and it'll just tell me like what are the total subweights of every tower. So if not tower dot what did I call them? I called them aboves. Let's return nothing. And let me, no, I don't know that I like that. So let's think about this. This one's actually trickier. Trickier than I was hoping for. That's okay though. We'll figure it out. So let's think aloud here, and let's use our example that they've given us. So when I want to look at Ugmil, so I want to determine the total weight of something and whether it is balanced. So let's check a tower, and I want to return the total weight and whether it is balanced. So subchecks equals name check lookups above for name in tower.above. So I'm getting these subchecks. Is balanced and so let's do subcheck weights equals weight for weight is balanced in subchecks.values, and this one is going to be balanced if subcheck weights is either empty, in which case it has no it has no towers above it, or if there's only one value in it, in which case they're all the same. And weight equals sum of weight for, again, weight. Maybe I didn't need these in a dictionary. In subjects dot values, and then I want to return weight is balanced. Okay. And so I'm going to just for tower in towers, actually, let me just do this. Print checking tower, print weight, print tower, weight is balanced. And then we'll do that. And then finally, I'll say, you know, root equals find bottom of the towers, and let's check the root. So let me comment out all this stuff because I just want to run this on my test. So let's say balance towers, test towers. And stir has no objects aboves. So print checking tower. So what did I do wrong here? Stir object has no checking tk and k. Stir has no object above. So somehow tower got it. Root equals lookups find bottom towers. So find bottom return the name, but I actually wanted to return the tower itself. Name above is not defined, so check lookups name. Okay, that will work too. Name subchecks weights is not defined. Subcheck weights. So checking this, checking this, checking this. Tower jigsaw has no above, so and I forgot to add in the tower.weight. So let me do that, and now let me run it again. And so now we got 251, which is right for UGML. We got 243, which is right for paddocks, and we've got 240. So 251 is too much. And so what we said is needs to be 8 units lighter. Given that exactly one program is the wrong weight, what would its weight need to be to balance the entire tower? Okay, so here's what I'm thinking. What I am thinking is that I want to freak out if len of subcheck weights is bigger than 1. So this is going to be the problem. We have unequal weights, and so we want to find the one that has to be fixed. And so one problem is that these have unequal weights, but we also want the first one, right? So, if something's out of balance, then presumably the ones below it will be too. So we want everything above it to be balanced. All is balanced for, I should not have made subjects a dict, but that's okay. For weight is balanced in subjects.items. Print subject weights. Let's do that. And so let's try that and see if it works. Okay, so that does work, but I actually want the counts, right? So I want, let me get a counter here from collections import counter. And so I want to print counter of weight for weight in subjects.items. And so I think that will tell me what I want. No, I don't want, sorry. I don't want items, I want values, I think. This is kind of messy code. Okay, good. So this tells me that, in this unbalanced case, I have two 243s and one 251. And so by the parameters of the puzzle, I can figure out what its weight needs to be to balance the entire tower. So I'm just going to, I could write some code to extract that, but I'm just going to run it actually and see what happens. Print, and let's make sure it's the same input too. Hasn't changed, still get your puzzle input. Print, I don't even need to print, I just call balance towers. Balance towers, towers. And now let's run it. And this says that I have this one where I have a 2553 that needs to be a 2548. So let's make sure what it wants. Given exactly one program is the wrong weight, what would its weight need to be to balance the entire tower? And so here's the issue that I still think this is probably not right. And why is it not right? It is not right because most likely this is not exactly 2553. Instead, everything above it is 2553. Okay, good. So this is why I did it that way. So, this is where the problem is. So for name and check is, this is not its weight, this is the total weight. So let me call this for name total weight and is balanced in subchecks.items. Okay. Tower let's call it above tower equals lookups name print name and total weight and above tower dot weight. So I think that will actually do what we want. Although there's actually a lot more of these than I expected, right? So why is that? Why did I get more of them this time? Because there's too many subjects? No. Let me do one more thing and just print tower to see where we're at. And so, you know, this is zsadger, and this is, so zsadger is above this guy. So why am I getting all is balanced? I don't think that should be the case, right? So here, length of subcheck weights is bigger than 1, and all is balanced. Whatever, I'll figure that out later. The important thing is that this guy is 5 too high, right? So if he were 1864, then that should be good. And I'm going to check that by looking for 1869, and you know, JDX, is that the guy? 1864? Yeah, so if I change him to 1864 and run it, then there is no problem. Okay, so good. So let's call him 1864. Given the exact one is wrong weight, what would its weight need to be to balance the entire tower? That is the right answer. I'm 1 gold star closer to debugging the printer. So that was, you know, a little bit ugly, and I still don't understand why it didn't quite work the way I wanted it to, but it worked well enough for us to find the right answer. So that took longer than I would have liked. But anyway, that's it. Oh yeah, should plug my Twitter, same as always. @JoelGrus. That's me. Follow me. Check it out.